Society did not say 1 second, 1 second, 1 second, 1 second, 1 meter, 1 meter, 1 meter, you're in a gravitational field. Your head is actually moving at a slightly faster rate than your feet.
The second law of thermodynamics says that things unwind and move forward, so that gives an arrow of time. But at the quantum world, in the micro world, the second law of thermodynamics doesn't seem to hold, and things can go backwards or be timeless.
The fundamental equations of physics have a property which is referred to as time reversal symmetry. And what time reversal symmetry means is that a set of laws, which are time reversal symmetric, are laws that have the following feature. For any process that's in accord with those laws, the same process going backwards is exactly as much in accord with those laws. Okay? That ought to mean that that milk jumps out of coffee as often as it dissolves into it, that people get younger looking as often as they get older looking, that we have the same kind of access vis-a-vis knowledge to the future as we do to the past, that by acting now we ought to be able to influence the past just as much as we can influence the future. All of that is wrong. All of that comes into violent conflict with the way we psychologically experience the world.
One of the most unpalatable ideas still, in spite of the fact that quantum physics has been around a long time, is the possibility or the notion that the future can have a causative effect on the present. We believe that the past can have a causative effect on the present. I hold the ball, I drop it, it falls. Cause, effect when it hits the ground. But could the ground be the cause of my dropping the ball in the first place?
It's only in conscious experience that it seems that we move forward in time. In quantum theory, you can also go backwards in time, and there's some suggestion that processes in the brain related to consciousness project backwards in time. For example, in the late 1970s, a neurophysiologist at University of California, San Francisco, named Ben Libet, did some very famous experiments. What Libet did was study patients who were having neurosurgery on their brains, with their brains exposed, while they were awake. They were given a local anesthetic to numb the area of the skull and scalp to access their brains. And they were awake, and Ben would talk to these people. So, for example, what he did was he would stimulate their little finger and look at the part of the sensory cortex on the opposite side that was related to that, record from it electrically, and ask the patient when he or she felt the stimulus on the little finger. And he would also stimulate at that particular area of cortex. Now, what you would think would be that if you stimulate the little finger, it takes a finite period of time to get to the opposite side of the cortex, so the patient would report it a fraction of a second later after the stimulus. And when you stimulate it directly, the patient would report it immediately. He found just the opposite. When he stimulated the little finger, the patient felt it immediately, and when he stimulated directly in the cortex, there was a delay. After sorting through all the data and repeating this over and over, Libet came to the conclusion that somehow the brain was projecting information backwards in time, so that it did take a finite amount of time to get to the sensory cortex, but the brain projected it backwards in time so that the conscious perception was that the stimulus was felt when the pinch actually occurred.
There have been some studies which have shown that when people are beginning to move a hand or beginning to say something, that there's actually activity in the brain in certain nerve cells of the brain, even before they become consciously aware of what they're trying to do.
I know it seems to me that I often do things and then decide a fraction of a second later what to do, but I've already done them.
Oh, great. You can always go back in time. What's the matter? Remember, it's empty.
How do you know this shit?
I read Dr. Quantum comics. Everybody thinks it's just kid stuff, but I know it's real. That's how I do my magic on the court.
So, what they taught us in school isn't really the way it is, and that our senses are playing tricks on us. You just gotta wonder, what is this reality that we find ourselves in? Quantum physics says it's all just waves of information. Do I believe that? I hope so. Yikes!
That's how I do my magic on the court.
Yeah, I always choose the Wonder Boy first.
Well, Dr. Quantum says everybody's got it. Everybody's doing it. Doing it constantly. Each and every time you look.
And here we are, the granddaddy of all quantum weirdness. The infamous double slit experiment. To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the back wall where they went through the slit and hit. Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So, when we throw things, that is, matter, through two slits, we get this, two bands of hits. And with waves, we get an interference pattern of many bands. Good so far. Now, let's go quantum. An electron is a tiny, tiny bit of matter, like a tiny marble. Let's fire a stream through one slit. It behaves just like the marble, a single band. So, if we shoot these tiny bits through two slits, we should get, like the marbles, two bands. What? An interference pattern. We fired electrons, tiny bits of matter through. But we get a pattern like waves, not like little marbles. How? How could pieces of matter create an interference pattern like a wave? It doesn't make sense. But physicists are clever. They thought, maybe those little balls are bouncing off each other and creating that pattern. So they decide to shoot electrons through one at a time. There is no way they could interfere with each other. But after an hour of this, the same interference pattern is seen to emerge. The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself to hit the wall like a particle. But mathematically, it's even stranger. It goes through both slits, and it goes through neither. And it goes through just one, and it goes through just the other. All of these possibilities are in superposition with each other. But physicists were completely baffled by this. So they decided to peek and see which slit it actually goes through. They put a measuring device by one slit to see which one it went through and let it fly. But the quantum world is far more mysterious than they could have imagined. When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently, as though it was aware it was being watched. And it was here that physicists stepped forever into the strange, never world of quantum events. What is matter? Marbles or waves? And waves of what? And what does an observer have to do with any of this? The observer collapsed the wave function simply by observing.
We are always the observer. But sometimes we identify with the event so much so that we even lose the aspect of the observer. That's why the materialist gets totally lost and thinks that we